Okay, guys, so we'll get started. Okay. So first, I'd like to talk about some review and the result of the survey. Okay, so last week I asked you guys to take a very short class survey here. Okay, so one more. When I saw it this morning, there were only 8 people taking this survey. If you haven't done so, please take the survey so I get some feedback. Okay, and I look at the general analysis about the pace of the class. 5 people think it's a little fast, and about the part that you want me to spend more time on, sensitivity analysis part. That's one topic I see a lot, and the other part, the problem solving hints and tips. This we will get a lot of practice throughout the semester. Okay, so that's something I'm not worried about. The solver table, I'm not sure what this about. Is that the solver window, that how to input the constraints, things like that. If you still don't know how to do this one, then I don't think it's my fault. Okay, you have to learn how to input the solver window by this time. Okay, if you're talking about the tables in sensitivity analysis, then that's probably the same thing. How to build a model, that's again, we'll get a lot of practices, even though in different chapters the problem will be different, but you get to practice them. Okay, they are connected. They are not just totally separated. Yeah, so mostly our sensitivity analysis. So, and that's what I saw also from last homework assignment 2. On average, the class did not do very well for that homework problem. I guess one reason is that I don't know how many of you did that optional exercise for chapter 4. That's the sensitivity analysis part. There was an optional one. And that one is more straightforward. Say just asking you, say, okay, what this value is about, whether there's alternative solution or not, and what is the problem you generate. If this value increase that much, how would that change the object function? So if you have done that optional exercise first, you get more practice on the sensitivity analysis part, and then you do the homework, because the homework is more practical. Okay, it's based on a specific problem, like a business problem, asks you to do some interpretation. So doing that optional homework exercise first will help. If you didn't do it, then still it's helpful to do that if you think you want more practice on the sensitivity analysis part. Okay. We'll see how much we can do. I don't plan to go back to talk about sensitivity, because if we talk about that's the same thing. And the key to master is first organize the knowledge in your mind.
Can you give us a solution at least?
I gave you the solution already.
The exam?
Yeah. To what exam?
The homework.
Yes, I gave you a solution already. Yeah. I think so. I posted. Yeah. Here. So that, for example, turning homework assignment 1 is that's in week 3. So here, in the resource of that week, let me see here. Now here, homework assignment 1 solution. So check that, and then homework assignment 2. Here, resource. Once you turn in the homework, for example, you turn in the homework on Wednesday. On Thursday, if I saw everyone turning the homework, I would put the solution here. Here. EMGT homework assignment 2 solution. So it's already online. Okay, if you don't see it, that means someone has not turned in the homework. I'm still waiting for a late submission. And when everyone turns in the homework, then the solution will be online. So please check it. And if you still have questions on this part, I think one thing we can do is give another review and maybe some example questions before the midterm. Okay, but at this moment, I probably won't go back to talk about sensitivity. I want you guys to spend some time on it. Okay. That's actually related to one comment that I forgot to make at the beginning of the class. Usually I tell students that based on the University of Minnesota policy, each credit of an undergraduate course is worth 3 hours of work. Okay, for that undergraduate student to get an average grade, which is a B. Okay, and for a graduate student in this class, this is a 3-credit class. For you to get an average grade, that means you need to spend at least 9 hours on this class. So we spend 3 hours in the class, and then that means 6 additional hours outside of the class for you to get an average grade. Okay, so you do the calculation. If you for this class, we don't have a lot of like reading assignments that take much time. The homework part is the part that get you hands dirty and do the practice, so you get to learn better and better. And I expect that once you get over that hurdle, know like when you see the problem statement, know how to formulate a problem. You grasp like the skills that, okay, when you see it, you say, oh, okay, these are the decision variables, and what's my objectives, and these are the indicate the constraints. Then it will be much faster for you to formulate a problem. And also, learning curve, you guys all know about the learning curve, right? It has a slow takeoff, and suddenly you reach to the part that's increase dramatically. And I expect everyone to be getting that steep part by mid of, so we have 15 weeks. So by week 7, 8, you should get to that part. Okay, and that includes the model formulation part, which is like the solver window part. Okay, but you do need to do your part, your homework. And especially for the solver parts, we don't have much time. You guys all know that how much it takes to go through an example, just one example in the class, and we will take up like 50 minutes. So I don't think I'm going to go through a lot of examples in the solver. I will tell you the key formulas to work and how. For example, chapter 5, we're going to go through one problem today. Just the solver part. Okay, then you learn the key formulas, and then you go home, do the practice yourself. Master those key formulas and the format to use. Okay, so that's the expectation on you, and yeah. So we look at the survey, and I think yeah. So that's the pace. So I can during the class, if you think I'm going too fast. Just raise your hand and say, okay, I just ask a question, okay, and slow down a little bit. But for the modeling part, and just besides the sensitivity part, for the modeling part, like how to analyze a problem, how to build a model for it, how to implement in solver, you will get much better with a lot of practices, okay. And this is not how to say. It's easy class because like its answer is right or wrong, right? So if you get it, then you get it. It's not like those other engineering management classes depend like which are more qualitative. Depends on your writing skills, things like that. This one is more straightforward. You have the answer, then you get it. But it's difficult or challenging another way that needs a lot of practice to get your mind used to the way of OR thinking. Okay, so but that part, practices help. Okay, some former students ask me like, okay, how do I improve my performance in the exam? I said, well, go do more. If you have time, go do more exercise problems from the homework section in your textbook. and if you want the solutions, I'll give you the solutions to check against. Okay, so that's maybe one way if you want to improve. And make sure if you want to improve, do those optional exercises problems. Okay. Okay, so that's what I want to talk about. Oh, and for the case presentation, for people like BJ, if for the case study presentation in the future, someone who's taking it online cannot make it, two different options. One is you can have your teammate here be the representative, okay? Because everyone has contributed a fair part to it, you don't have to be here to do the presentation if it's not worthwhile. But if you want to come, you are more than welcome to come. And it's nice to come once in a while to meet people here, right? Okay. And the other way will be you pre-record your video, the parts that you are presenting, and send it to your teammates. So we'll just have like a team with two real person here and one video. Okay, so I'm pretty flexible to the options here. Okay, then, yes?
Do we just need to return in one copy of the report per team?
Yeah, just one report.
So it doesn't
Yeah.
matter who turns it in?
Right,
Okay.
right. I think if one person turn in, it's automatically update on Moodle. Yeah, it says like the entire team. Yeah,
Just curious.
sure,
So
no
when you
problem.
Turn in IDs and get plagiarism checking, I was afraid that if two people turned it in, it might flag them as
Oh,
plagiarized.
that's an interesting point. I'll see that. Okay, but I think just one person turning will be good. Okay, then review for chapter 5. Unfortunately, I was sick, really sick last week. My entire family got sick. That's what happens when you two young kids who go to daycare. And when one got sick in the daycare and the entire family got knocked down. I look at the class exercises I asked you guys to do. So I asked you to watch the video and do the exercise. I think almost everyone did it. If you didn't do it, you should have done it. Okay. And everyone who turned in the answers did a great job. So now let's look at what we covered last week. Oh, maybe let me ask you. The first problem we talk about is a transshipment problem. Okay, what's the difference between a transshipment problem and the transportation problem we covered earlier in chapter 3?
The transshipment has nodes that don't receive anything permanently, that passes through them, potentially.
Okay,
So, I mean, they
okay.
can receive things permanently, and in some of the cases they can't. They have nodes
Okay.
where stuff's passing through, but that stuff doesn't
Passing
stay
through.
there.
Okay, so there are nodes that have stuff that's passing through. Okay. Or if we use the terms that we use in chapter 5, those transshipment nodes have inflows and outflows. Okay, good. And later we talk, then the second problem we talk about is the shortest path problem. Okay, and the shortest path problem is a special case of a transshipment problem. In that case, we just assume that what's the supply and what's the demand?
Same.
What's the in the shortest path problem? What's the supply and what's the demand? Yeah, they are the
Supply
same.
is 1 and demand is 0.
You just said they are the same, right? Okay.
Yeah.
So we assume the one supply and the one demand. Remember that? In the video I said, you just think about it in a way that you're just transporting one car from the starting point to the destination point. Okay, so that's the shortest path problem. And then the third one we talk about is the generalized network flow problem. That problem, here, this one. In those kind of problems, the flow does not always stay the same on Arc. Okay, so when you send out a certain amount of flow from a node, when it reaches to the destination, the flow may increase or decrease. Okay, and in that specific example here, the flow decreased because of the yield rate are not 100%. Okay, some loss happened on the arc. And for this problem, there are two challenges. Okay, mainly two challenges. First is how to come up with that graph, this network graph, from the problem statement. Okay, In the previous two problems, the network is given. So it's pretty clear winch node to winch node. But in this one, this is the first business problem that we transformed into a network problem. And we'll look at one more today. Okay. And one challenge is to think in terms of network. Okay. Like in this case, we used those raw material as the starting points. And since those raw material went through two different steps, so we had some middle points, transshipment nodes, representing the two recycling process. And the end product, which are those three types of paper pulp. These three paper pumps, we represent them as three destination nodes. Okay, so one challenge and one key learning point from this problem is how to transform a business problem like this into a network. Okay, and the second thing is deciding the sign to use. Oh, before that, let me ask you, what are those? What is that rule that we follow when we create constraints in all network problems?
Flow minus outflow.
Okay, what's the rule called? Do you guys remember?
If supply greater than demand.
Okay. So based on the relationship of the total supply and total demand, you decide the signs for the constraints, right? So it's called the balance of flow rule. And all the constraints in the network problem, we put them in the format inflows minus outflows, greater than equal to, less than equal to, or equal to the supply or demand of that node. And the sign is decided by the sign between your total supply and total demand. Okay, remember that? And so that's the balance of flow rule constraints. And in this generalized network flow problem, the second challenge is to determine the sign to use. Okay, because the starting volumes is not the same as the ending volume because of those yield rate. So in the situations, if we can decide the relationship, for example, if you use the total supply multiply the minimum yield rate here, and it's still greater than the demand, then you know you are able to meet the demand. Okay. Or if you use the total supply multiply the maximum yield rate here, and it's less than the total demand, then you are sure you can't meet the demand for sure. So in these two situations, you can be sure what the sign to use on all your constraints. Okay. Otherwise, what do we do? If we are not sure about the relationship of the true supply and the demand, what sign do we put?
We assume that the supply meets the demand.
Okay. Okay, so we assume that we can meet the demand, so we use the greater than equal to sign and solve the problem. If the problem turns out to be infeasible, that means it's not going to meet. Then you switch the sign and then resolve the problem. Okay, so that's what I want to review for what I talked about last week.